Alright, so this is the question of the day on day 3. So we have to, well, first let me graph this equation. So as we can see, since on the numerator you can see these 3 factors, we know the zeros have to be x equals 1, x equals negative 2, and x equals 3. So we know that at these places, let's see, okay. At those 3 dots, those have to be the x-intercepts. And if we look at the denominator, we can see that the asymptotes are x equals 0, x equals 1, and x equals negative 5. But now, if you notice, since we see the x equals 1 here and here on the numerator, we know that has to be a whole or removable discontinuity. So let's just make a whole like that. So, and if you see this, we can see that since there are 3 x's here, that means that the degree on, and then 3 x's on the bottom, the degree on the top is the same as the degree on the bottom, which would mean that the asymptote has to be a 1. The asymptote has to be a y equals 1. And then, of course, you have the vertical asymptotes on the bottom as well. So let's just use a red. Yeah, let's use red, and let's make these asymptotes, the vertical ones. Whoops. Not that. So we know that one of the asymptotes is at x equals 0. And then the other asymptote is at x equals negative 5. So right here. Whoops, that's not straight. Alright, let's straighten that. And then we can just, I guess, plug in values to actually, and then, okay, never mind, not plug in values. Since the asymptote is at y equals 1, or actually, yeah, let's just plug in values to see from which side it's approaching the asymptotes. So on this side right here, we have to look at I know. Let's just plug in something like negative 6 to see where we have to be. So that would be negative 6 minus 1 is negative 7. Negative 7 plus 2 is negative 5. Negative 7 minus 3 is negative 10. All over negative 7 times negative 8 times negative 2. So this would be negative 350 over that would be, no, 56 times negative 2, that would be negative 112. So that's roughly that's about 3. That would be, that would simplify to roughly 3, just a little under 3. So that means we know that at negative 7, so right here, at negative 7 we would be at 3. And since we know that the asymptote is at y equals 1, we know that it has to be going down, like this. Sorry, not going down. If it has to be going up. And then we can look at some of these other things as well. So since this is at -5, if we were to plug in something like -4, we can see where we have to go as well. Just erase all of this. So -4 minus 1 is -5. -4 plus 2 is -2. -4 minus 3 is -7. And then on the bottom you would have -4 times -5 times 1. So that would be equal to 10 times -7 is -70. And then those bottom three multiplied together is equal to 20. -70 over 20 is -3.5. And that is roughly right here. So that would mean that this would be going up like this. Well, of course, remember, there's an asymptote right here, so we have to see where it goes from here. So let's just go through there. Yeah, now we also have to see where it goes from here. So if you go really close to 0, let's just say -1, we can further plug in some more values again. -1 minus 1 is -2. -1 plus 2 is 1. -1 minus 3 is -4. And then you would have -1 times -2 times 4. That would end up being equal to 8 over 8. So that is just equal to exactly 1. So that means it appears that it would be going up like this. And then we can see that since they're alright, so now we have to solve this problem. So basically, I have to take this big log and simplify it. So already I can see this +7 and this +4 right here. It looks like these would be the h and k values. So let's just write this out like this. Alright, so we already have that. And so now I guess you could just try out points, and then you would end up getting log of 1/2 times x plus 4 plus 7. That's just what I got after I just guessed and checked a few values, and that's what I ended up getting. So as you can probably also put in quite a few values. So at the y-intercept, it's roughly 0 and 7.3. So 1, 2, 3, 4, 5, 6, 7.3. So it's roughly like that. And then you can put in a few more values. Like we can also try putting in -2, and -2 gives you exactly a value of 7. And then obviously we have our asymptote right here at -4. And then one last point that I just found by graphing and plugging in values is roughly 4 and 7.6. 4 and 7.6. So it would be roughly like that. So we can just draw it like that. And then it would just go something like that. So as you see, the domain is everything, all real numbers that are greater than -4. So it would look like that. Our range appears to be all real numbers from the looks of it, so it would be -infinity to infinity. Our end behavior would be as x approaches infinity, y approaches infinity, and x never really approaches infinity, but as x approaches -4, y approaches infinity, or -infinity. And yeah. So our asymptote will be at, let me just move this over a little bit. Our asymptote will be at x equals -4, as we've already established. And let's see. Our pivot point will be our pivot point will be I don't believe that there's like any proper whole number pivot point, but I'd say our pivot point appears to be at 2 and -7. So or -2 and 7, sorry, not 2 and -7, so I'll just write that. So now that we have to find the inverse of this above function, let me just copy and paste it. It's actually there's actually an easier way to go about doing it than just trying to solve for y. So basically what we could do is basically just try to reverse every aspect of this. So since the 1/2 is on the outside, you have to take the reciprocal of it. And sorry, 1/2 is on the inside, so we have to take the reciprocal of it and put it on the outside. This log over here has to be changed to an exponential, and obviously since there's a hidden 10 right here, there's a log base 10 hidden right there. Basically this 10 base would then become the base in the new function. And then this +7 that's over here would then become a -7 and go on the quote-unquote inside on an exponential function. So basically what we could do here, this 10 would become the base. And then since this 7 is on the outside and positive, it would go on the inside and become negative. And then since this 1/2 is on the inside and it's a 1/2, we're going to take the reciprocal of it, put it on the outside. And then since we have this x plus 4 on the inside, it's going to go on the outside and become a -4. And then we can put the inverse sign on the left, and that's all that's an easy way to get the inverse function. And basically what we have to do here, we would just have to reflect this across the x-axis, or sorry, not x-axis, the line y equals x, because we are looking at an inverse here, and that's what inverses are. They're reflected across the line y equals x. And now in order to find the asymptote, we just have to look at this value right here, and this value is a -4. So our asymptote will also be at x equals -4. Sorry, it's going to be at x equals -4. And obviously, if you were to reflect this across this line, you would get something like this, right? You'd get something like that. So that's obviously exactly how our function is going to look here. It's going to look something like this. But obviously, since we need to get actual points, we can just plug stuff in and we can find out. So if we plug in, let's just say 0. Actually, no, let's make it easy. If we were to plug in 7, 7 minus 7 is 0. 10 to the 0 power is 1. 1 times 2 is 2. 2 minus 4 is negative 2. So actually, we were pretty spot on here when this rough sketch that we drew. So yeah, it would be 0 and negative 2. Then we can try out some more values. Like if we were to have whoops, actually no. Well, no, I'm not doing this right. It would have to be x equals 7. And 7 minus 7 is 0. 10 to the 0 power is 1. 1 times 2 is 2. 2 minus 4 is negative 2. So it would be 7 and negative 2, not 0 and negative 2. Let's fix that. It would look like that. And then we can try plugging in some more points as well. So 8 minus 7 is going to be equal to 1. 10 to the first power is 10. 10 times 2 is 20. 20 minus 4 is 16. Actually, that would not be on this graph. Let's try 6 then. 6 to the negative 7 power is 6 minus 7 is negative 1. 10 to the negative first power is 1/10. 2 times 1/10 is 1/5. 1/5 minus 4 would be negative 15. No, well, 1/5 minus 4, which is equal to 20/5, would be equal to negative 19/5. Yeah. Okay, so that would be almost 4, but not quite. So it would be something like that. And obviously you can this would just be like off the graph, like over here, and then anything else would just be like increasingly closer. So it would be something like this. And let me just draw it like that. And our domain is going to be all real numbers from the looks of it. Our range is going to be, as you can see, we have a restriction. The asymptote is at negative 4. It's not going to go any lower than that. And it's actually not ever going to even touch negative 4. So we would use a parenthesis, and then it would go to infinity. And behavior is that as x approaches negative infinity, y approaches negative 4. And x approaches infinity, y approaches infinity. Asymptote, we've already established this. This would be x equals negative 4. And the pivot point, we can just look at the pivot point on this last one, which we determined to be negative 2 and 7. And we could reflect it across this point. So it ended up being right here, which would be 2 and 7 and negative 2. 7 and negative 2, so right here. 7 and negative 2. And let me just erase all of this. And we are done.